who you at? I will take you out. You do this.
Okay, as I've always said before, write down as much or as little as you want to, but you're responsible for all of it. So you know what you need to write better than I know what you need to write. I'm just writing pretty complete stuff up here just to reach the least common denominator. So Newton's second law, I already told you that, F equals ma.
Guys.
Shh. So the people at home can hear it. Force, or wherever they're watching this from maybe in the future, equals mass times acceleration. Hopefully all of you are algebra savvy enough to know that ma means they're multiplied, but just in case you're not. Ooh, and I always forget this, but I want to add this in. This is not just force, but let's call this net force. It's not an NF, but it's important to say that that's a net force. And don't draw this picture unless you really want to. This is going way beyond what you really need to do. If you have a car and it has a bunch of forces on it, let's say gravity's pulling it down at 60 newtons. This is a weird car, it's not very heavy. And the ground is pushing it up with a force of 60 newtons. And the motor is pushing it forward with a force of 80 newtons. And friction is, and it's going this way. And friction is pushing it backward with a force of 20 newtons. What's the net force on that car? What is it and which way is it? If you use this formula, F equals ma, to find the force acting on that car, you're not going to find, it's not going to give you 60 or 60 or 80 or 20. It's going to give you one number, and that's going to be the net force. So what would that number be? It would be 60 which way? To the right. Because these two forces are balancing one another. They cancel each other out. And here we've got an 80 Newton force to the right, 20 newtons to the left. That one's going to win. So the net force, if you watch this car and you massed the car, you put it on a big scale, you typed in the mass, you multiply that by how fast it was accelerating, you would get a force equal to 60 newtons to the right. So that's the net force. And it's important to say that we're not calculating each of these. It's just when you put all those together, you get the net force, and that's what you're getting from this formula. Okay, mass. What's a one-word definition? My word begins with S. Guess what it is? Not a bad word. What? Stuff. The amount of stuff in something. And the reason I use stuff is because if I don't, then I wind up with some circular definition like what you find in a dictionary. If you look this up in a dictionary, it'll say mass, the amount of matter in an object. And then if you look up matter, it'll say anything that has mass. So it doesn't really get you anywhere. Everybody knows what stuff is, sort of. Can you think of something that doesn't have mass? A thing with no mass? Does air have mass? Is there stuff in it? Yeah. If you're going fast enough, it can burn your face off. Just from rubbing against it. What's something that doesn't have mass? First thing I think of is love.
Love?
Yeah. Gravity, I guess you could say gravity doesn't really have mass. It's got to be some sort of idea, really. If it's a thing, it has mass and it has stuff. I also want to say mass is a source of inertia. Mass and inertia are not the same things, but if you have mass, then you have inertia. And anything that has inertia has mass. So if you try to push something and it kind of pushes against you, it resists a little bit, then it's got some mass because it has inertia. Cross out the word base here because what I want to write is not the metric base unit. I want to write the unit that you need to use all the time in all these formulas. Anytime you put the mass into F equals ma, you need this unit. Can you guess what it is? Not the base unit. There's the base unit, which is grams, and then you add all the prefixes to that. What do you think the unit we'll be using is? Anybody a drug dealer in here? Got a big brick of cocaine?
I saw that.
How much mass does a big brick of cocaine have? A kilo, yeah. So this is going to be kilograms. I'm glad to hear there's nobody who's a drug dealer who works with bricks of
Nobody
cocaine in
spoke
here.
up.
Nobody spoke up. Yeah. If you do, I guess you would be too savvy to say, wouldn't you? What's that? Yeah, I was telling another class about this, that last year, at the intersection of physics and drug dealing, do you hear about the drug dealers who were throwing bricks of cocaine across the border from Mexico with a big catapult? Made a kind of cool catapult. They were eventually caught and it was confiscated, but I don't know how much they actually got across. The abbreviation is kg, and I want you to know what a kilogram is. It's about, this isn't very useful because you hardly are familiar with newtons, but it's 9.8 newtons. And that comes from this formula. If you multiply 1 kilogram times the acceleration of gravity, which is 9.8, you get 9.8 newtons. So you could also say it's about 10 newtons. But more importantly, how many pounds is a kilogram?
1,000.
No. A kilogram is like a brick. Remember I said the kilo of cocaine thing? If you pick up a red brick like you'd find in a house, it's about 2 pounds. If you just want to say 2, that's good. I'm going to put 2.2. It's like a brick. Not a cinder block. Not the big concrete things, but the little clay things that they make houses out of. Volume really doesn't matter as far as Newton's law goes, but it's in here because a lot of people think volume is mass and they get confused. So I want to talk about what volume is so we can say, not that. So what is volume? Mass is the amount of stuff in something.
Space.
Yes, volume is the amount of space an object takes up, or an object occupies. But I'm just going to go ahead and end my sentence with a preposition anyway. I'm not even going to use a period, a capital letter. So that's volume. Oh, and just if you just want to use one word, size. That's what volume is. Weight. Guess what the answer is that I'll say, no, we need more than that. The people usually give me. Weight is what? Weight and mass are different. How much something weighs, very good. A lot of people say how heavy something is. And yeah, that's true, but what determines how heavy something is? There are two things that determine weight. Gravity and mass. The more stuff you have, the heavier you're going to be. And the stronger gravity is, the heavier you're going to be. So that's great. So it's the force of gravity acting on an object. And you don't have to really write this, but I'll just say, like the formula for it, F equals ma, that's the general formula for force. F equals ma can become W equals mg. So instead of F in this specific kind of formula here, I've got W, which stands for the force of gravity. So it's still a force. Mass is still mass. G, what does G stand for? Acceleration of gravity. It's just a specific way of saying negative 10 meters per second squared. So if you ever want to know your weight, and you don't want to give it in pounds, you want to be metric, just find your mass in kilograms, multiply it by negative 9.8 if you want to be precise, and then you've got your weight in newtons. Now the point of this is, at this point I want you to practice and just see if you get the definitions. The way these things work, they're objects. Object B, this is the boundary of it. This circle doesn't contribute any mass to it. The dots are the mass. These are identical particles of mass. Everything else is just empty space. So it's an empty vacuum except for those dots. And this just shows you where the edge is. That doesn't have any mass either. So go through those and see if you can figure out which one has the most volume, least volume, most mass, least mass, most weight, least weight. There's one trick question here. glad to find you awake.
Volume, like the circle. Metric.
Okay, time to go over the answers. Which one has the most volume? Volume is the amount of space it takes up. Size. Which one's biggest?
C.
B. Least volume.
C.
C. Those are probably the, if somebody didn't really know anything, they were just guessing their way through this, and they saw greatest, least, they'd probably guess those things. So volume is the one that intuitively makes the most sense. Which one has the most mass? A. It's got the most stuff in it. It's not the biggest, but it's got the most stuff. Least mass is C. Oh, not C. Not C. What is it?
D.
D. Yeah. Sorry. Which one's heaviest? Is it gonna be the biggest one or the one with the most mass? Most mass.
Yeah, for sure.
So the more stuff you have in you, if you're just totally empty but really big, you're not going to be very heavy. But if you got a lot of stuff in you, even if you're not large, you'll be heavy. Least, lightest, D. So the answer to which has the most mass and which is the heaviest, those are always going to be the same answer, except in a really special circumstance. And if you go to the doctor and you stand on one of those special scales where they move the slider across, that they call that a balance, and they say that you're measuring mass. You kind of are measuring mass with those things. If you took one of those to the moon, it would still work. It would still give you your mass. It would give you your weight incorrectly. I don't know why I'm saying this. This is kind of confusing. I'll come back to that in a second. So number 4, in outer space, which one's the heaviest?
C. Yeah, no.
How much does this one weigh in outer space?
C.
Let's use the formula for weight, which is force equals mass times acceleration. We just put in, let's say that these are each a kilogram, so 6 kilograms. What's the acceleration of gravity in space? 0 meters per second squared. So the force of gravity is going to be 0. And it's 0 for all these. It doesn't matter how much mass they have, if there's no acceleration of gravity, they're going to have 0 newtons of force. So the answer is none. Or you could say all, but none of them weigh anything. Number 5, in outer space, which one has the most mass? A. Now, I'm only drawing this because I kind of opened my mouth when I shouldn't have. The way scales work, a lot of scales are like this. This is just a dumb example. Just imagine a spring underneath the platform, and if you stand on this spring, then you can see how much you push the platform down. And if you push it down more, then that tells you you're heavier. Like to here, you might be 100 pounds. And here, you might be 200 pounds. So if you take this setup to the moon, where there's less gravity, is it going to work the same? No, it won't. You won't compress the spring as much because you're not as heavy. So this kind of a scale wouldn't work on the moon. On the other hand, those doctor's scales, they're kind of like this. They're not really. They look like this, and it's got something over here and something over there, and you slide these things back and forth. And it's a complicated way of doing this. Here's some kind of a fulcrum, and you add some weights. If these are each 100 pounds, then this would be or each of these is 100 kilograms, then you would be 200 kilograms. If you took the same setup to the moon, would it still work like that? Would you still balance 200 kilograms? If you did this on Earth, here you are, there's 200 kilograms of mass, you're both perfectly balanced. And then we move the whole setup to the moon, would you still be perfectly balanced? Yes or no? Yeah, you would. This would be, there'd be less gravity pulling this down, there'd be less gravity pulling you down, but you'd both decrease, you'd still balance. So this is kind of a measure of mass more than this thing is. This is like just a measure of weight. Sorry for mentioning that. Kind of got us off on a bad tangent. The first three things over here, these are just practice using the formula. This is really straightforward. I just want you to see how I'm using the formula. A 2 kilogram mass accelerates at a rate of 3 meters per second squared. What force caused this? This is a straightforward, write down the formula, plug stuff in. What's the mass? Is that 3 or is that 2? In this situation, is the mass 3 or is the mass 2? 2 kilograms. It really doesn't matter. You could get screwed up and you could do it the wrong way and you're multiplying things so you get the same answer. And I'm not requiring you to do it, but if you do the correct thing with all these units, you wind up with 6 kilograms times meters over seconds squared. And that's another way of saying 6 newtons. So you could do all that, remember that that's newtons, and then convert to newtons. Or you can just remember, anytime you're doing any of these problems, make sure you start out using kilograms for your mass, meters per second squared for the acceleration, and you're going to wind up with newtons. I'm not always going to write that. I'm just going to go right from this to newtons. So number 7, you've got an unbalanced force acting on a 7 kilogram object, and it's causing that object to accelerate at a rate of 8 meters per second squared. Somebody blurt out, what's the force acting on the object? Somebody say 56 or 6? 56. Yeah, the force equals the mass of it times the acceleration, and you get 56, and the units are newtons. That's like 56 quarter-pounder hamburger patties that are raw. At least the weight of those. Because of what I've already said, I think this is just going to be too easy, but do it anyway. A 3 kilogram bowling ball is dropped from an airplane. Gravity causes the bowling ball to accelerate at a rate of what? -10. And we could use 9.8 if you really wanted to get it right. But this is good enough. What was the weight of the bowling ball? Can anybody just tell me what the weight would be without writing it all out? 30 newtons. Now, if I was a smarty pants, I would say, no, that's wrong. -30. I'll take either one. So, I'm just going to write F equals ma. To figure out the weight, we can just use that formula because weight is a force. And you multiply the mass of the bowling ball times the acceleration of the bowling ball. And we get -30 newtons. I'll take 30, I'll take -30, it doesn't matter. Technically it's -30, why? And well, which way is the force? Force of gravity is downward, so technically you should always have negative forces for gravity. But it's okay. With weight, a lot of times you don't do it that way. 9 and 10, you can do those now. I'll have you do them in a minute. 11, this is something that's got a little bit of a twist. You've got the gray dog and the black dog, and they're both tugging on this rope, and you know the mass of the rope, and you have to fill in, and you also know the force with which the gray dog's pulling, and you have to fill in 2 things. You have to fill in the net force acting on the rope, and you have to fill in the force contributed by the black dog. So which one can you get first? How do you get the black dog's force?
Um, 5 newtons times 1 kilogram. No, 5 newtons equals the mass 1 kilogram times 2 meters per second squared.
So if you say 5, if you just use F equals ma and you put this in for F, and you put this in for the mass, and you put that in for acceleration, then you have 2 times 1 equals 5. But remember, so that's, we're barking up the wrong tree there. So back with, at the beginning of the page, I told you that F equals ma, that gives you a net force. So if you just start out figuring out what's the net force on the rope, then that's the logical way to proceed. So the net force on the rope is what? Anybody tell me? Use Newton's second law. What's the net force on it? 2. So this is that force equals this mass times that acceleration. 1 times 2 is 2. So the net force is going to be 2. Not negative 2, but positive 2. And if the net force up here, if I add it into the diagram, I'll make it, yeah, somebody's already got the black dog. Let me just write this out. F equals 1 kilogram times 2 meters per second squared equals 2 newtons. I'll write it here, and I'm going to draw it in up here. Positive 2 means it's going to the right. So that's the net force. If we know that's the net force, and these are the 2 component forces, these are the 2 individual forces that give us that, what does that have to be? 3. And remember back to the last time we talked about that, I was telling you that a net force, that's like a scoreboard. It tells you who's winning and by how much. So if the net force is positive 2, that means it points to the right. That means the gray dog is winning by 2. The gray dog's force is 2 newtons stronger than the black dog. So what's 2 newtons less than 5? It's 3 newtons. So right now what I want you to do is do number 9, 10, and then this other one over here with the SUV, and then we'll be all done with this. Oh, and to make things easier, let's just say that the acceleration of the Earth's gravity is 10, and on Mars it's 4. If you want to use 3.77 and 9.81, go ahead. But if you don't have a calculator and you don't want to get one out, you can just use 4 and 10. Once we're done with this, we're done. The next sheet is the homework assignment. The SUV one is a little bit tricky. It's not too bad, but make sure you've got your wits about you when you do that one. For this one? Yeah, for the bottom. So just by it shouldn't be left or right. I know. So the acceleration of the right now is to the left. It's getting faster. And through that, I say, what's the velocity? What's the name call it? The velocity negative 50. But you're right. I mean, if you hear velocity negative, you would think it would be faster.
Yeah,
But it's not, it's the reference is just in ours. It's on this paper, so if the thing's pointed that way, we say it's going backward, even if somebody's driving it that way. In reality, if you had a movement odometer, it wouldn't say negative.
So this is what is
This is just first and second one. Okay, I want to go over the answers and set you free-ish. So the weight of the child on the earth, I think everybody I checked had this right. I'm going to write it as F equals ma this time and do it differently next time. Weight is the force of gravity, so I can just call this F. The mass of the child is 30 kilograms. The acceleration of the child is 10 meters per second squared. You could say negative 10, and it's technically more correct. And I get 300 newtons. So I'm going to write it a little bit differently here. I'm just going to write W equals mg. It's the same formula. You just see people use that more often when you're talking about weight. Weight equals the mass of the child on Mars, and g is gravity on Mars. So on Mars, g is about 4 meters per second squared, and the child would be 120 newtons. So looking at this chart, if you go to Pluto and you jump off a tall building, which doesn't exist on Pluto, but if it did, every second you would speed up by that much. So after 10 seconds, you would still only be going about 4.2 meters per second, so you still wouldn't be over 10 miles per hour. You jump off, fall for 10 seconds, and you'd be going about 10 miles per hour. You could just land and be fine. Now for this, to get the net force, use Newton's second law, mass times acceleration, and you get negative 2,000 newtons. Now, so I'm going to write negative 2,000 newtons. One thing that is confusing about this is if you were in that vehicle, you would say, I'm going forward. But all of us, we're looking at this thing on this screen, and we're thinking of it like an XY coordinate system. It's going to the left, so we call that negative. We're going to say it's moving in a negative direction. It's got a negative velocity. If it were going downward somehow, we would call that negative. If we were going upward, we call that positive. To the right is positive, just like a coordinate system. Has nothing to do with which way the thing is facing. This is just the way we interpret all these negative numbers. So negative 4 doesn't mean the thing is slowing down. It just means it's accelerating leftward in this field of view. So now I'm going to add that net force, or this net force, to the picture, and I'm going to put it in a pictorial way. I'm not going to put the negative on there. I'm just going to show what the negative means. Negative 2,000 newtons means 2,000 newtons to the left. Now you could do this, you could think about this mathematically, and that's another way to do it. But I'm just going to say 2,000 newtons to the left, and use that as like my scoreboard. And the scoreboard tells me this force is winning, and it's winning by 2,000. It's 2,000 greater than that. So this has got to be 3,000 newtons. Wouldn't be negative 3, well, it is negative 3,000, but in my picture, since I have this arrow, the negative would be redundant.
She said negative 2,000.
Oh, I'm sorry. Yes, well, same thing. In my picture, I wouldn't write